All right, let's throw some objects. So you're going to do a problem. We got a rock thrown downwards at a 15-degree angle below the horizontal from a height of 10 meters. We want to know how far does it land from the base of the cliff. Simple projectile problem, except we threw in a little quirks here for you guys because you're the best of the best and I know you can do it. So your goal is to figure out how far did it land from the base of the cliff. So we're looking basically for delta x here. All right, give it your best shot. See what you can see. I'll come back with the answer. All right. So pause the video and we will discover what the answer is. All right, here's what I got. Delta x, 19.22 meters. All right, so let's see how I got that. So first of all, I'm certain you drew a wonderful force diagram. I mean, it's a projectile, so really a force diagram is just gravity. So you did that in your head. But you also drew a wonderful picture of the scenario. So let's make sure we got that right. So here's my picture. My computer is super fast. You'd think it was a government issue or something. All right, there we go. So it was launched at a 15-degree angle below the horizontal. So it's actually thrown downwards at an angle. So here's my drawing. Here's my arc. There's my initial launch. So maybe that alone might solve some problems for you. So like I said, if that you realize, hey, there's my mistake, pause the video, go forward from there. But if you still don't have that aha moment, then I'm sure you did a fantastic job of identifying your x and y variables. So in a beautiful list, come on, you can do it. So there we go, x and y variables. So here's my x velocity. 20 cosine of 15 because it's at an angle, so I have to use sine and cosine to break it up into its individual x and y components. I'm looking for how far it went, and I don't know the time. These are the only three variables I'm going to have because in the y plane we have constant velocity because, like I said, if you draw a force diagram, then the only force you have is gravity. So in the y plane we have acceleration, but in the x plane we have balanced forces, so thus constant velocity. Then I look in the y-plane, because I can't solve it, but I know time is the link between the two planes. So in the y-plane, my initial velocity is negative 20 sine of 15, because I'm pointing down, so that's the negative initial velocity. I'm in free fall, so I have a negative acceleration of 9.8, and since I'm falling down, my displacement's going to be 10 meters. So I can use this to solve for time, because here I have 3 out of the 4 variables from my kinematics equation. So at this point, with all this stuff, you should be able to throw it into some kinematics equations, solve for time, use that to get to the x-plane. So I'm going to kind of pop those through, so see if they make sense to you. So let's kill this. Go away. So here's where I'm solving for the time. So I've got delta y equals v sub dot delta t plus 1 half at squared. My displacement is a negative 10. And once you do all this, that's a quadratic, folks. Yep. Well, it's a real thing. All right, so use your calculator. You can graph it. You can do a polynomial solver. Maybe you got a quadratic solver, whatever, but you can get that in. You can get your time. Once you get your time, then you're going to look in the x-plane. And since the x-plane is constant velocity, we only have one equation, and that's the equation for constant velocity. So I'm just going to sub everything in, solve for delta x, and I get my 19.22 meters. All right. So if you got any questions, please come and see your teacher or chat with some friends or whatever floats your boat. But hopefully that solves some problems or at least dislodged some things, and hopefully you got it right in the end. So I'll see you next time. Have fun with physics.